Hi class, this is the first of 4 videos on arguments, and first of all we're going to be breaking them off into slightly smaller nublets for processing's sake. You want to make very sure that you understand and grasp the main concepts of this video before moving on to the next one, etc., etc. All the argument stuff builds, so make sure to watch them in order, make sure to take some time to practice and think and find examples, and participate in the discussion boards between these videos is the best way to learn it. So first of all, why are we doing this? Remember the Russell. So last class we learned, well, Russell's definition of philosophy is one in which we pursue truths that cannot be determined empirically. So first and foremost, if we want to generate truths, but we can't use our microscopes and our telescopes and our sense data, then ultimately our vehicle for doing that is going to be argument. That's what argument is. It's a truth generator. It's pretty cool. Second, though, and this is kind of the more subtle connection that you're not going to get in, the pure logic courses, etc. It has to do with what we call justification. Remember that all-important question in philosophy is why. So a very important question and kind of a philosophical mindset we talked about in the Russell video is asking important why questions of the form, why do you believe X? And here's the connection with argument. If I'm going to try to answer the question, why do I believe X? My answer is actually going to be an argument with X as its conclusion. So there's this very close connection between justifying your beliefs, which you should do with all your beliefs at some point, and with argument form. And so learning arguments is going to help clarify our thoughts, clarify our beliefs, and evaluate what we should believe. So it's hugely important. Very sad that they don't teach logic and critical thinking in all high schools. But so we're going to get, if this was in class, it would be about a week and a half worth of crash course in logic that we simply must do in order to do what we should be doing in philosophy. So that's what we're up to. As you're following along, be aware that there's this resource in Unit 1 called the Argument Summary. That has lots and lots of definitions of all these terms I'm going to be giving. So if you just want to kind of sit back and listen, be aware that you have all these definitions in other pages. But we're going to start, obviously, with the definition of argument. So this is not the colloquial shouting match type of argument. An argument is something else. It's something meant to establish that we should believe something, or that we should believe something is true. So all arguments, and before I even say this, the rest of this lecture, next lecture, we're just going to be saying arguments. And so we're going to be talking about what makes something an argument, which is very, very different than what makes something a good argument. And so we're talking about the things that all arguments, good or bad, persuasive or not, have in common. So when I say all arguments, don't try to mentally translate that to good arguments, or you're going to get yourself in trouble. So all arguments do 2 things, or anything that does both of these things is an argument. Any argument does both of these things. What are these 2 things? All arguments make 2 claims. They make a factual claim and an inferential claim. Emphasis on the word claim, because claiming something doesn't make it the case. That'll get into evaluation later. So, what is a factual claim? It's just a claim that something is true, the claim that the world is a certain way, etc., etc. So, a factual claim could be something like, Mickey Lurkowski, this guy is over 6 feet tall. For that matter, a factual claim could be, this guy, Mickey Lurkowski, is over 12 feet tall. Both of those are factual claims. They are presented as a claim that something is true. And notice eventually when we get to evaluation, we'll realize which of these claims is good. So that's a factual claim. But just factual claims doesn't make it an argument, and this is a spot where you might want to glance through that argument summary page, and they talk about all these things that aren't arguments. Things like reports. Reports are just a list of factual claims. There's no argument because there's no inference. So the second part of an argument, something that every argument does, is what makes an inferential claim. That is the claim that these facts lead to some further fact. So Mickey Lurkowski is over 6 feet tall. Therefore, inference, he's over 5 feet tall. That would be an example of a really simple argument. We're going to say quite a bit more on this, of course, but before we do that, why am I putting so much emphasis on the fact that every argument does two things? Because that also means, as an entailment, every argument has two evaluations. You have to evaluate both claims, and the most common place where students get in trouble is trying to merge those two completely separate evaluations. And so, as a challenge, as something you might want to think about, try to think about a couple of combinations, such as an argument that has good facts, that is a good factual claim, but a bad inferential claim, that is, they try to infer something you can't infer, or vice versa, perfect inference on bad facts. That's something that is a really good exercise to kind of cement the fact that these are two very separate things in your mind. So let me give you just two really quick examples. Well, a couple examples. So one we've mentioned before, Aristotle, father of logic, gives the following as kind of the paragon case of an argument. He says, all men are mortal, Socrates is a man, therefore Socrates is mortal. Probably worth writing that one down. All men are mortal, Socrates is a man, therefore Socrates is mortal. Now, is this an argument? Well, the father of logic says it is, so it probably is. But let's talk about why. What are the factual claims here? What's key for a factual claim is that it's unsupported. Someone simply presents it as something to be accepted. And so if you've written those down, you should have 3 sentences. All men are mortal, Socrates is a man, therefore Socrates is mortal. Notice the difference. Just with those 3 sentences on your sheet of paper, do those give you any reason to think that all men are mortal? No, it's simply presented. That's indicative of a factual claim. Given just those 3 sentences on the paper, is there any reason to think Socrates is mortal? No. Once again, it's just presented as something to accept or reject. By contrast, with just those sentences on the paper, are you given reason to think that Socrates is mortal? Yes. It seems to follow from the fact that all men are mortal and Socrates is a man. I'm wondering if I said that right. So, all men are mortal, given no reason to accept it. Socrates is a man, given no reason to accept it. Socrates is mortal. You are given reason to accept it. So the first 2 are factual claims. Having said that, careful. The last is not an inferential claim. Because think of what an inferential claim is. It's the claim that those facts, all men are mortal, Socrates is man, lead to some further fact. So that further fact cannot be the inferential claim. Instead, pretty subtle point, the inferential claim is the word therefore. It's the indicator that from these 2 facts, you're supposed to infer, inferential claim, the third fact that Socrates is mortal. So with that argument, yes, factual claim, because it claims all men are mortal and Socrates is a man without support. Inferential claim, the word therefore tells me that those 2 facts are supposed to lead to this last fact. So that's why it's an argument. However, we are now going to introduce slightly different terminology. I know, it's a little annoying. In an argument, the factual claims are called premises. The singular is premise. So why are there 2 different terms for it? Because something can have factual claims without being an argument. So the definition of a premise is specifically the factual claim of an argument. So premise all men are mortal. Premise, Socrates is a man. Inferential claim is therefore, what's that last claim then? That's called the conclusion. So another way to define the inferential claim, if you like this a little better, the inferential claim is the claim that the premises support the conclusion. And in that little easy argument I gave, the word therefore does that. So, all arguments must make an inferential claim, must make a factual claim. Let me just give two examples of where one's good and the other's not. And we'll talk a little more about how to evaluate them in the next video. So, if I made the following set of claims, you might say, well, Mickey Larkowski, this guy, is over 12 feet tall. Therefore, he's over 10 feet tall. Well, is that an argument? Stop yourself there. I didn't ask if this was a good argument. I asked if this was an argument. So what do we look for? Is there a factual claim? Is there something simply presented as a fact? Yes. It's stated without any support that Mickey Larkowski is over 12 feet tall. So there is a factual claim there. Is there an inferential claim? Yes, the word therefore is the same vehicle again. That's the claim that the fact that Mickey Larkowski is over 10 feet tall follows from the claim that Mickey Larkowski is over 12 feet tall. So that is an argument. Now, you'll notice, you'll start to see why we have to have two separate evaluations. Does that argument have a problem? Absolutely. But what's the problem? It's not the inference. The inference is perfect. It does follow from the fact that Mickey is over 12 feet tall that he would be over 10 feet tall. The problem is the fact. It's simply false that Mickey is over 12 feet tall. And so we'll refine this in the next 3 lectures, but for now, that's kind of our paragon case of bad factual claim, good inferential claim. And so, but we can have the other one as well. So we could start with perfect facts. Mickey is wearing a red shirt. Therefore, it's going to rain tomorrow. Well, does it make a factual claim? Yes, it simply states Mickey is wearing a red shirt. That is a good factual claim. And yet it's a terrible inference. It doesn't follow, and we'll have to talk about why later, from the fact that Mickey's wearing a red shirt today, that it's going to rain tomorrow. And by the way, that's the case even if it does rain tomorrow. That's still a bad inference, and that's an important point we'll have to return to later. So, the high points from this, what is an argument? An argument is structured reasoning that tries to tell you that you should believe something, which we will now call the conclusion. So an argument gives reason to believe the conclusion. How does it do that? By making a factual claim and an inferential claim. It claims that the world is a certain way. It claims that certain things are the case. In an argument, those claims are called premises. And the general goal is to show that the argument's premises lead to the conclusion. That leading to is the inferential claim. It's the inference. Does one support the other? And so I always like to think of arguments in terms of support. The premises are what are intended to do the supporting. The conclusion is what is intended to be supported. So if you're ever having an exercise where you're trying to figure out which statement is the conclusion, think in terms of support. You are theoretically given reason to accept the conclusion in a way you are not given reason, not given support for the premises. So that's what arguments do. Now, here's a question. Given that we have to do 2 evaluations, and we absolutely must, which one do we do first? The answer is we check the inferential claim first for 2 reasons. And one reason is just kind of a practical reason. Most of the time, it is much, much, much easier to check the inference than the facts. So imagine if I said to you, Mickey is over 6 feet tall, this guy. Therefore, Mickey is over 5 feet tall. How long does it take you to check that inference? Well, I simply ask myself, is 6 more than 5? Yep. Done. Good inference. How long would it take you to check the facts? So we are obviously in a remote format, so how in the world would you check my height? You could maybe email me and ask me and hope I answer you honestly. You could question some people who have met me in person, et cetera, et cetera. But whatever you do, it's certainly going to take you longer to confirm that Mickey is over 6 feet tall than it takes to confirm that 6 is more than 5. So for the purely practical reason, we check an inference first because it's faster. Here's the kind of more philosophically rich reason we always check the inferential claim first. Cannot emphasize this enough as I pound on my desk to make sure you get this point. I cannot emphasize this enough. If the inference is bad, the facts do not matter. Period. Let me say that again. If the inference is bad, the facts don't matter. And that's a very common mistake. Well, if I start from good facts and I have a bad inference, people somehow still think that argument's good. No. To take a really exaggerated case, suppose I said, well, Mickey is wearing his purple socks, therefore, there's going to be a freak blizzard tomorrow in August. In that kind of bad inference, I hope you realize my socks have nothing to do with the weather. Would you even bother in planning your day tomorrow to check the color of my socks? No, of course not, because it doesn't matter what color my socks are if a blizzard doesn't follow from them. So that's a really exaggerated case, but the less exaggerated it gets, the more people are prone to just making this terrible leap in their minds that somehow the fact that the facts are true is going to somehow outweigh the fact that the inference is terrible. Bad inferences, as soon as you realize the inference is bad, you're done. It doesn't matter if the facts are true, doesn't matter if the facts are false. If the inference is bad, we're done. We have to return to the drawing board, etc. And that's actually really important to realize. Another thing in your logic summary packet, that was made for a logic class, so we're not going to get into it. But just if you're interested, the ones that are numbered with a 3 list fallacies. Fallacies are very common bad inferences. And they're committed so often, but remember, combine that with what I just said. As soon as we say, if the inference is bad, the facts don't matter, and you realize how very common it is to make these bad inferences, there's a whole lot of arguments that should be rejected. Let me just give you one quick example. Again, this is mainly more than we're doing in the class. There's an argument form called tu quoque. It's a fallacy. It means you too. People do this in arguments all the time. If you're in a fight with your significant other, it happens in two-party politics to a point that it nauseates me. The general pattern is if I say to my spouse, you shouldn't do X, and her response is, but you do X, whether I do it or not is utterly irrelevant to whether she should do it. Very similarly, if you criticize a Republican, oh, you shouldn't do X, and they reply, well, the Democrats did it last time they were in power, utterly irrelevant. That has nothing to do with whether you should do it. So that is a fallacious form of reasoning, which means it is definitionally a bad inference, which means we should automatically reject the conclusion, period. And yet, we are fooled by this kind of fallacious inference hundreds of times in a year, and so it's something we should really train ourselves out of. So while all the fallacies that are listed towards the end of the argument summary packet are optional, you'll be a better person if you really familiarize yourself with them and stop using them and stop being fooled by them. So, but the more important point and what you need to know for this class, if the inference is bad, you're done. If the inference is bad, the conclusion cannot be established, and the facts don't matter. Next video, we are going to start evaluating inferences. And we're going to do that with the deduction and induction split. So watch for that, and we will see you next time.